Hi everyone, welcome back to our set theory series. In lesson 1, we learned what a set is and how to write it. Today, we're diving deeper into the language of sets. You will learn about elements, subsets, and the universal set. By the end of this video, you will be able to identify elements, determine subsets, and understand the universal set. Let's get started. To denote that A belongs to A. So if A is an element of set A, we write it as follows: A belongs to A, or A is an element of set A. If B is not an element of set A, we write it as B doesn't belong to A, or we can read it like B is not an element of the set A. Examples: A is the set of 1, 2, 3. Then 1 is an element of A. The same goes for 2 and 3, but 4, for example, is not an element of A. Let B equals the set of apple, banana. Then banana is an element of B. Apple is an element of B, but orange, for instance, is not an element of B. So again, the elements of the set don't have to be numbers. Here we'll define a subset. A subset is a set that whose elements are all contained in another set. So here, let a B be a subset of A. So a set B is a subset of A if every element of B is also an element of the set A. Notation: B is a subset of A. If B is not a subset of A, we write B is not a subset of A. So we use these symbols. One for denoting that B is a subset of A, the other one for denying this, or for saying that B is not an element is not a subset of A. Of course, B is a set, A also a set. So sometimes we have B is a subset of A and also A is a subset of B. But in this case, A is equal to B. So A has to be B, or to equal B, in order for all elements of B to be contained in A, and also all elements of A to be contained in B. Examples: let A equals the set of 1, 2, 3, 4, and B equals the set of 1, 2. Then we ask whether B is a subset of A. So we will simply check if all elements of B are also elements in the set A. So what are the elements of B? The elements of B are 1 and 2. So is 1 an element of A? Yes. Is 2 also an element of A? Yes. So we conclude that B is a subset of A. Of course, A contains other elements, but we just focus on the elements of B. Let C equal to the set of 1 and 5. Then C is not an element of A, but why? C has two elements, 1 and 5. Is 1 an element of A? Yes. But is 5 also an element of A? No. So there exists an element of C that is not also an element of A. Therefore, C cannot be a subset of A. C is not a subset of A. Special cases: every set is a subset of itself. Of course, because every element in A is already in A, so A can be considered as a subset of itself. And this applies for any given set A, arbitrary set A. And the empty set is a subset of every set. If you remember that we discussed about this in the last lesson, that all sets, or you can say that every set contains phi, no matter what the elements of or the other elements of this set be. So now phi is a subset of every set. Phi is a subset of A. Then we'll define the universal set, denoted by capital U or big U. It is the set that contains all the objects or elements or members under consideration. It acts as the universe for our particular discussion or problem. So we define the universal set U, or we denote its elements every time we use it. Like here, U is the set of natural numbers. Therefore, U is the set of 1, 2, 3, 4, 5, etc. Here it is an infinite set, but it doesn't have to be infinite. So we have another example of U to be the set of to be the set of A, B, C, D, etc. till Z, like it's the English alphabet. So it is a finite set. What's the use of this? We'll see. Here in these practice problems, please pause the video, try to answer the problems or solve them yourself, then check if you got the right answers. And here are the answers. Okay, first problem, let A equals the set of 1, 2, 3, and 4, and B equals the set of 2 and 4. The question is B a subset of A? So we check, is 2 an element of A? Okay, so 2 being an element of B, is it an element of A? Yes. We continue, is 4 an element of A? Yes. So these are all the elements of B, and they all, or both of them, are elements in A. Therefore B is a subset of A. Of course, if A was something like the set of 5 and 4, so if we ask whether 5 is an element of A, then we find out that A doesn't have any 5s, so we shouldn't continue and ask whether 4 is also an element or is an element of A, because we found already an element of B that is not an element of A. But here in our case, all elements of B are elements of A. Problem 2, let U, the universal set, equals the set of 1, 2, 3, 4, 5. So this is our universal set. Is the set of 3 and 6 a subset of U? So here, the set of 3 and 6, we can name it as the set of, or B equals the set of 3 or 6 and 6, or we can just say the set of 3 and 6. So is it a subset of U? Here we check for the members or the elements of this set and see if all of them are in the universal set. So is 3 an element of our universal set? Yes. Is 6 an element of our universal set? No. Therefore the set of 3 and 6 is not a subset of U. Problem 3, identify the elements of the set. C equals the set of A, E, I, O, and U, the English vowels. Is E an element of C? Yes, E is an element of C. So here in this problem, we just check that we understand what an element is. So if I ask you, is W an element of C? you will check and see if the set of or C contains W. No, so therefore W is not an element of C. So we just made sure that we know what an element is. So today we learned about elements, subsets, and the universal set, and the notation of this. And that's it for today's video. Thank you